Imagine cutting a temple downward through a mountain, moving an 800-ton block without an engine, or hiding a city 18 levels beneath the earth. Across the world, ancient builders created structures that still challenge scale and precision. Some survived earthquakes without mortar. Others controlled water across cities, aligned stone with the sky, or transformed cliffs into homes. These places do not prove lost supermachines. They reveal how planning, simple tools, and immense human effort can produce astonishing results. From Peru's mountain walls to a 150-ton prehistoric roof, how did ancient people make stone seem impossible? Our journey begins above Cusco, Peru, at Sacsayhuamán. 3 levels of polygonal walls climb the mountainside. Some blocks weigh more than 100 tons, yet their irregular edges meet so closely that mortar was unnecessary. Every stone locked against its neighbors like part of a 3-dimensional puzzle. The Inca had to quarry, transport, lift, and position these masses on steep ground without modern machinery. Their interlocking geometry was more than decoration. When earthquakes shook the region, the stones could move while the larger wall remained stable. Centuries later, much of this 15th-century masonry still stands, preserving precision and resilience. Segovia connects architecture, landscape, defense, and water. A fortified palace occupied a rock rising roughly 180 meters. Visitors approach through a giant lion gateway whose paws remain. Below, gardens follow geometric axes through reservoirs, bathing pools, moats, and fountains. The water network ran from the rock's base to the summit. Built in the 5th century, Segovia did not treat stairways, gardens, water, and fortification as separate projects. Everything belonged to one vision. The site seems suspended above the ground, but its deeper achievement is turning difficult terrain into a connected environment. India's Kailasa temple at Ellora reverses normal construction. Instead of building upward, craftsmen carved downward from a hilltop, releasing a Hindu temple from one solid mass. That demanded planning from the first cut. A serious mistake could not be corrected by replacing a block because columns, walls, rooms, and sculptures remained connected. About 400,000 tons of rock are believed removed, yet no nearby waste area appears large enough to explain it. Many surfaces are smooth, with obvious tool marks difficult to identify. Some accounts and legends suggest work took about 18 years, a breathtaking possibility with 8th-century hand tools. Near Japan, the mystery moves beneath the sea. Yanagani is not assembled from blocks. The bedrock forms broad terraces, flat plains, sharp angles, and straight channels. Against an irregular seafloor, these features resemble steps and platforms from a submerged complex. Some observers argue that people modified the rock while it was above water, placing the work thousands of years in the past. Many geologists offer another explanation. Natural fractures, rock structure, and erosion could have created the geometry. The evidence remains debated. Yanagani shows the boundary between a compelling pattern and confirmed construction. It looks designed, but appearance alone cannot settle who, or what, shaped it. At Chand Bauri in Rajasthan, geometry descends almost 30 meters underground. About 3,500 stone steps repeat across 13 symmetrical levels. From above, the stepwell resembles an inverted pyramid or maze. Keeping those lines aligned required control of dimensions and angles without modern surveying instruments. Yet its design served practical needs. The deeper levels remain cooler than the surface, creating relief from dry heat while providing access to water. Chand Bauri transforms an environmental challenge into monumental architecture. Its power comes from repetition, but its success comes from function. Every flight guides movement downward, and the stone creates a cooler refuge. The Roman aqueduct at Segovia solves another water problem. 2 tiers of arches rise nearly 29 meters and contain more than 20,000 granite blocks assembled without mortar. Gravity locks the arches and pillars together as weight passes through the structure. But crossing the valley was only half the task. Water traveled roughly 15 kilometers along a slight, continuous descent. Roman surveyors used the chorobates, with plumb lines and still water, to compare elevations section by section. Those measurements became one descending route that carried water in the correct direction using gravity alone. The aqueduct looks monumental, yet its most important feature is the nearly invisible slope making everything work. At Angkor, water engineering reached city scale. The world's largest religious monument stood within an urban landscape covering hundreds of square kilometers. Builders transported sandstone about 40 kilometers from Phnom Kulan through rivers and canals. Reservoirs called barrays, embankments, and channels stored rainy season water and distributed it during dry months. This network is why Angkor is called a hydraulic city. Its monuments belong to a system moving people, stone, and water. Eventually the center was abandoned and forest reclaimed much of it, leaving the scale of its planning as an enduring question. In Greece, the walls of Mycenae and Turin were so immense that later Greeks credited the Cyclopes. That legend gave us the term Cyclopean masonry. Huge rough limestone boulders were stacked with little or no mortar, while smaller stones filled gaps and stabilized the walls. Much of the work dates to the 14th and 13th centuries BC, when Mycenaean civilization was near its height. Unlike Peru's closely fitted polygonal walls, these fortifications relied on mass, placement, and packed irregular material. Centuries later, the scale seemed so extraordinary that mythical giants became an explanation. The myth was wrong, but it preserved a genuine reaction to extraordinary human labor. At Chichen Itza, the Pyramid of Kukulkan makes light and sound part of its architecture. Its 4 stairways are commonly associated with the 365 days of the year. Near the spring and autumn equinoxes, sunlight produces triangular shadows along the northern balustrade. As the sun moves, they form a feathered serpent apparently descending toward the ground, linking the pyramid's geometry with the sky. Sound adds another effect. A handclap before the staircase can return an echo resembling a quetzal bird, although deliberate design remains debated. Here, stone does more than carry weight. It frames a seasonal performance and transforms ordinary sunlight and sound into a memorable experience. In Ethiopia, Lalibela is architecture by subtraction. 11 churches were carved into volcanic rock below ground and connected by trenches and passages. Beti Giorgis stands out as a freestanding cross-shaped mass when viewed from above. Its roof, walls, columns, and openings all came from the original rock, so workers had to control every cut while moving downward. Nothing could be assembled later to hide a major mistake. The result feels less like a building placed on the earth than a space revealed inside it. Around 8 centuries later, these churches remain active centers of pilgrimage and religious life. Lalibela is both an ancient engineering achievement and living architecture. The Great Pyramid of Giza turns precision into overwhelming scale. Roughly 2.3 million blocks formed a structure over 146 meters tall. Each base side measures about 230 meters. Yet their lengths differ by only a few dozen centimeters. Its faces align closely with cardinal directions, with errors of only a few arc minutes. Egyptians may have used sledges and ramp systems, but no single model explains every stage. The pyramid needs no unknown technology to astonish. Coordinating millions of actions with this accuracy demanded surveying, logistics, labor, and organization on a scale still difficult to reconstruct after 4,000 years. Rome's Pantheon has stood nearly 2,000 years beneath an unreinforced concrete dome spanning more than 43 meters. Builders controlled the load by changing materials as the dome rose, heavier near the base, then progressively lighter toward the top. This reduced mass where the structure needed it most. Studies of Roman concrete also show that lime clasts can react with water and form minerals that seal small cracks. That mechanism has not been demonstrated directly in the Pantheon, but it reveals a durability strategy unlike ordinary concrete. Roman builders were not pouring one uniform mixture. They adjusted weight and material to structural demands, inspiring modern research into self-healing concrete. Stonehenge's greatest puzzle begins before the stones reach the site. Saracens weighing around 25 tons came from West Woods, about 25 kilometers away. Bluestones traveled more than 250 kilometers from Wales. Neolithic communities needed coordinated teams, ropes, sledges, and prepared routes to move them. Once erected, the monument aligned with the sun, incorporating summer and winter solstices. Its complete purpose remains unsettled, with interpretations ranging from ritual and remembrance of the dead to marking seasonal cycles. Stonehenge was built and altered over more than 1,500 years, roughly 100 generations. It was not one frozen plan, but a project repeatedly inherited and reinterpreted. At Baalbek, a few stones create a gigantic puzzle. 3 limestone blocks in the temple foundation, the trilithon, each weigh about 800 tons, roughly equal to 2 Boeing 747s. Their joints are so tight that a knife blade could barely fit. Nearby, another block over 1,000 tons remains in the quarry, apparently abandoned because it was too heavy to move. Ropes, wooden sledges, and human power are believed to have helped. Many historians think Romans built the Temple of Jupiter over an earlier foundation, but who first positioned the largest stones remains unclear. Even modern cranes would struggle with them intact. Back in Peru, PX terraces reshape an entire mountainside. Curving agricultural levels follow the slopes, and the complex is believed to resemble a pizica bird from above. Across the valley, cliffs hold thousands of ancient tomb niches. Beneath the planted soil, layers of stone and gravel drain water, store warmth, and reduce nighttime frost. Different levels create microclimates supporting several crops on one mountain. The stonework holds soil, limits erosion, and remains stable through heavy rain and earthquakes. PX looks like landscape sculpture, but it was a practical farming system. Its beauty emerged from managing water, heat, soil, and unstable terrain. Mohenjo-Daro resembles a modern city plan buried in the distant past. By around 2500 BC, its streets followed a grid, and millions of fired bricks had nearly uniform proportions. Many homes contained bathing areas, toilets, and drains connected to underground sewers. This sanitation and standardization in a city more than 4,000 years old remains remarkable. The achievement was not a single monument but a network serving everyday life. Streets, houses, water, and waste followed shared rules, suggesting organized planning across the community. Why the civilization declined is uncertain. Theories point to drought, flooding, and environmental change, but its silent streets preserve both an urban triumph and an unanswered ending. Far into the Pacific, Nan Madol is a stone city built on a coral reef. More than 90 artificial islets connected by canals contain residences, ceremonial areas, and royal tombs. Long basalt columns were stacked like logs without mortar. Some stones weigh tens of tons, and walls rise about 7 meters. Every piece crossed water before being placed on coral, although the islanders had no wheels or metal tools. The scale was so unusual that Pohnpeian traditions explained stone transport through magic. Legend cannot replace engineering, but it captures how impressive the work seemed. Nan Madol shows a small island society organizing a monumental city in the ocean. Underground at Saqqara, Egypt, the Serapeum hides 24 enormous stone sarcophagi. Each box and lid together weighs around 60 tons and uses hard stones such as granite, basalt, or diorite. The blocks pass through narrow corridors before reaching deep side chambers. Traces of rollers, rails, and wooden winches show practical movement methods, while sand helped lower boxes into position. Their broad interior planes, clean corners, and polished surfaces remain remarkable. Finishing such hard material would be demanding in open daylight. Doing it with blocks weighing tens of tons inside confined tunnels turned the work into an achievement of transport, control, and precision. Göbekli Tepe in southeastern Turkey disrupts the familiar sequence of civilization. More than 11,000 years ago, hunter-gatherers raised T-shaped pillars up to 5.5 meters tall, some weighing close to 10 tons. With stone tools, they carved foxes, snakes, and wild boars long before metal or the wheel. The centers of 3 major enclosures form a nearly equilateral arrangement, suggesting advanced planning. This was not a random scatter of stone. It was organized monumental work by communities once considered too early for such architecture. After centuries of use, the enclosures were gradually buried beneath debris, and the exact reason remains uncertain. China's Yangshan quarry preserves a colossal plan never completed. In 1405, the Yongle Emperor ordered 3 sections of a giant stele carved for his father. The completed monument would have weighed more than 31,000 tons, with a base exceeding 16,000 tons. The Ming Chaoling Mausoleum stood about 20 kilometers away, making transport nearly impossible. Even if moved, a body of almost 9,000 tons had to be raised before a head over 6,000 tons could be placed above it. The project was abandoned, leaving rectangular masses attached to the mountain. Yangshan reveals exactly where grand ambition outran a workable plan. Across Peru's desert, the Nazca lines create a canvas too large to understand from one position. Hundreds of straight lines, trapezoids, and geometric forms cross uneven terrain while maintaining steady directions. Enormous birds, monkeys, and spiders reveal their proportions only from elevated viewpoints. The puzzle is how builders controlled scale and direction when they could not see an entire figure from ground level. Broad trapezoidal strips make the plateau resemble a modern infrastructure plan. More than 2,000 years later, the extremely dry climate has preserved much of this design. Nazca shows that precision does not always tower upward. Sometimes it stretches beyond ordinary vision. At Karnak in Egypt, stone becomes a forest. The Great Hypostyle Hall contains 134 sandstone columns. 12 central columns rise more than 20 meters, while 122 surrounding columns stand around 12 meters tall. Together they once supported a massive stone roof through beams above them. The center rose higher than the sides, creating clerestory openings that admitted light. Repetition became structural language. Column after column formed a load-bearing grid, not simply an open hall. More than 3,000 years later, much of this forest survives. Karnak shows how modular planning creates strength and awe, surrounding anyone who enters rather than presenting only an exterior monument. On Easter Island, hundreds of moai traveled from the Rano Raraku quarry to platforms kilometers away. The Rapa Nui had no draft animals or machines capable of carrying them. One theory suggests teams kept a statue upright and pulled ropes alternately from both sides, rocking it forward as if it walked. In 2012, an experiment with about 18 people showed the method could work. It also matches local traditions, saying the moai walked to their final positions. This does not prove every statue moved identically, but it demonstrates how balance and coordinated force can solve an apparently impossible problem. More than 900 moai preserve that mastery of movement. At Pumapunku, worked stones resemble a modular building system. Famous H-shaped andesite blocks have flat faces, right angles, and regular grooves. Repeating forms suggest they connected with other architectural pieces. In some places, Tiwanaku builders carved shaped sockets and cast copper alloy directly into them to join stones. This makes the blocks look prefabricated rather than individually shaped by hand. Their crisp internal angles still inspire debate over exact methods. Yet the stone tells an important story without fantasy. Builders thought beyond single blocks to standardized connections. Pumapunku's futuristic appearance comes from ancient decisions about repetition, fit, and assembly. Montezuma Castle in Arizona is a 5-story dwelling suspended inside a limestone alcove. Built nearly 900 years ago, about 20 rooms sit roughly 27 meters above the Verde Valley. The Sinagua carried stone, wood, and mud up the cliff, creating living space where almost no level ground existed. Wooden ladders connected floors and controlled access. The alcove shielded rooms from sun and rain, while elevation helped protect them from flooding along Beaver Creek. Its south-facing position kept rooms warmer in winter and cooler in summer. Instead of fighting the landscape, builders used the cliff as roof, defense, climate control, and foundation. Derinkuyu takes shelter to another scale. Carved into soft volcanic rock, the underground city descends as many as 18 levels, containing homes, animal stalls, food stores, wine cellars, schools, and churches. Ventilation shafts brought air below, while vertical wells supplied water and kept it separated from possible poisoning at the surface. During war, around 20,000 people and their animals could shelter here. Heavy circular stone doors rolled shut from inside to seal passages. Vast amounts of rock were removed, yet the maze has stood for thousands of years. Derinkuyu feels less like a cave than a complete urban survival system. Gunung Padang sits inside an archaeological controversy. It appears as a hill with 5 terraces covered by naturally formed polygonal stone columns. A disputed theory proposed that it could be the world's oldest pyramid, perhaps extending tens of meters underground and dating beyond 20,000 years. Scans revealed layers that some researchers believe people altered. But the columns themselves formed naturally as volcanic lava cooled, and the larger claim remains controversial. That distinction matters. The landscape may contain significant human modification without proving every spectacular interpretation. Gunung Padang asks us to stay curious while separating what a site suggests from what evidence establishes. Our last structure predates Stonehenge by thousands of years. Nearly 6 millennia ago, builders at Megaliths turned a roughly 150-ton slab into a Neolithic roof. 32 massive stones form the monument, and its capstone ranks among prehistoric Europe's heaviest moved megaliths. Geological analysis traced the stone to a quarry about 850 meters away. Builders may have dragged it downhill on sledges over wooden tracks, then used ramps and counterweights to raise walls and position roof slabs. The walls lean slightly inward and support one another, forming a deliberate load-bearing system. Menga's achievement lies in understanding weight, slope, balance, and teamwork without modern machines. Across these places, one lesson returns. Ancient engineering was not one secret technology shared worldwide. It was many societies solving different problems with available materials, landscapes, knowledge, and labor. Some questions remain open. Others become clearer when experiments show how ropes, sledges, gravity, water, geometry, and patience work together. We should neither dismiss ancient builders as primitive nor replace them with unsupported fantasies. We should recognize the intelligence written into their structures. Which would be hardest to recreate today? Baalbek stones, Derinkuyu's underground world, Giza's precision, or something else?